Every year, broken LT lines put thousands at risk. Delayed detection leads to tragedy. Manual patrols waste hours. Each delay risks lives and cost crores in losses. Introducing SLMS, Smart LT Line Monitoring System. Real-time detection under 1 minute. Accuracy within 10 meters. Powered by AI, edge computing, and GPS precision, SLMS transforms fault management into real-time action. Reducing accidents, cutting downtime, building a safer tomorrow with SLMS.
Hello everyone, here's our project, Smart LT Fault Management System. For our project, we will be using an edge device, Raspberry Pi or ESP32. The Raspberry Pi or ESP32 will continuously sense the data for tilt, current, voltage and other data and will continuously send it to the centralized software. On our centralized software, we will have a Django backend which will continuously run the ML and DL model. Our model is based on the PyTorch. The model will make decision whether the data presented has some anomalies or it's severe. Based on the data presented by our model, the LangGraph AI agent will further take decision. There's also a human in the loop. Based on the agent reaction, a human can also interfere in it. Now, every time before taking any action, agent does consult a human. So the actions are basically three: either ignore it, isolate the line, or call for the worker to physically verify it. And even human can give some other response if he needs to do so. Now let's look on our LMS app. Okay, so for this LMS app, I've simulated a synthetic simulations where we try to depict how the real world scenario takes place. So right now we are having a medium severity anomaly. AI conference is 74.7% and it occurred at 8:36 p.m. Now, tilt was within limits, leakage is at acceptable limit, current was normal, but voltage we can see is above the normal ratio. Okay, while we were talking, another anomaly has occurred. Based on the anomaly, you can choose three actions as I've said. You can either isolate the line, call the local worker, or skip the action. If you don't want to choose from either the three and you want to know more about the anomaly that has occurred, you can also talk about it without the AI agent. Now, let's stop these anomalies for now. Okay. So, for the simulation, this is the city LT map. Now, we have of course used synthetic data, that's why it's looking a bit clustered, but on the real world data, it will be a lot more practical. Okay. So the green and yellow, so the green is the normal, yellow signs anomalies, and red marks the high severity. Again, one more. Now, this is how the grid overview will look like. And this is how each of the anomalies will look like, and based on what that we need to take the action. This here gives our model performance. We reached the 97.3% accuracy. Of course, it was synthetic data. Like the data was not for Kerala state or any Indian state. It was the data of an American state. So I don't know how much it can be used for Indian state. That's why right now it's synthetic. Of course, there are chances of false positives, and we have a really fast response time of 1.2 millisecond. We continuously perform above 500 scans every second, and there's also real-time system. Here it gives data of all the lines, normal, anomalies, and all the line breaks happening.